Hey everybody, this video is going to be about heat pumps. For those that don't know, I have a heat pump on my house to keep the place warm when I'm not home running the wood stove. When I'm at work, usually this thing's running to keep the place warm, or of course cooling the place during the summer. And I think when properly installed and properly sized for the home, that can be very effective at heating your home and not using too much energy. You know, heat pumps are a much more efficient form of heating with electricity, and in many cases they can actually be more efficient and sometimes cheaper to operate than a gas furnace. But there is one thing about heat pumps that I just absolutely cannot stand. It just bugs my mind to think of it. Is the defrost control that many of these things have, including what this one used to have. A lot of heat pumps out there have, especially ones that are operating in colder climates like here. This is actually more of a mild climate, but it gets below freezing quite a bit here. But anyways, a lot of heat pumps, they have to occasionally defrost the outside unit when heating the home. That's because the outside unit acts like the evaporator of an air conditioner. It's just an air conditioner flipped backwards during the wintertime. So the outside unit, the outside coil gets cold, and when water collects on it, if it's below freezing, it condenses as ice. And eventually, that ice has to be removed. Now, one would think that to design a defrost control, you would analyze the outside air temperature along with the outside coil temperature. Well, a lot of the better quality defrost boards do this, but there's a lot that actually don't. See, in the early days before electronics were really common, defrost controls on heat pumps were mechanical. They were based off of time and temperature. You would have a mechanical clock timer, and you would have a sensing like a sensing bowl or something hooked into the outside coil to measure its temperature. Once it gets below freezing, it will start accumulating runtime in the compressor. And once 30 minutes, 60 minutes, or 90 minutes is reached, it will go into defrost. Well, as electronic defrost controls became more common, sadly, many of them still use the same dumb logic. Because, let me tell you, this one here, for example, when I moved into the place, it still had its original time temperature defrost control, and it was set to 30 minutes. So essentially the way it works is there was a defrost control switch hooked to the outside coil. Once it got down to about 36 degrees, it would close. You would hear it would actually click shut. And it would not open until it reaches about 80 degrees. So for a place like this that doesn't have too much of a load, when the unit's not running all the time at 40 degrees, for example, when the thing cycles off, any frost that accumulates during that run cycle will just melt off. So the way it works is, that switch would close, and then the electronic defrost control would start counting runtime of the compressor. And this also it's cumulative. So if your unit runs for 5 minutes, shuts off, it would be 6 cycles, and then boom, you'd have a defrost cycle if the timer's set to 30 minutes. This is such a dumb idea. It's such a dumb waste of energy. Because I'll be honest with you, with time temperature defrost controls, more often than not, there's no reason for the thing to be defrosting, but it's out there defrosting, running your electric bill up sky high. Because when these things defrost, they switch back into an air conditioner, and you can either put up with cold 50-degree air coming out of your vents on a 30-degree night, or your backup heat will come on to warm the air back up. So let's say if it's like 19 degrees outside, and your heat pump is running constantly, barely able to keep up a load without the help with the electric backup heat, on a time temperature defrost control board, the thing will defrost every 30 minutes, 60 minutes, or 90 minutes. And when it goes into the defrost, it either comes out of defrost once the switch clicks back open, or 10 minutes has passed. So when it's 19 degrees outside, chances are pretty good that it's not going to be able to warm the outside coil up to 80 degrees, especially if there's a wind blowing. And let's be honest, the amount of frost that accumulates on the coil really depends on the outside humidity. If it's a dry, cold night, you're not going to get much frost, but if it's humid, yeah, you'll get lots of frost. So there have been times where, most of the time, this thing would be defrosting with absolutely no frost on the coil, but there were a couple of times where it had a nice buildup of snow on the outside of it, and it was still waiting for its 90 minutes to pass up, because I had it set to 90 minutes. And when your heat pump's backup heat is electric heat, let's say if you have a 10 kW strip in your air handler and your electricity is about 10 cents per kilowatt hour, that electric heat will cost $1 an hour to operate, not including the energy of the blower fan and stuff like that. So think about that. So for example, here the electricity rate is about 8 cents per kilowatt hour in the wintertime, so it's 80 cents per hour. So let's say if it's really cold outside and your heat pump is having to use the backup heat occasionally, well, it gets much worse when your time temperature defrost control is making unnecessary defrost of the outside unit when, again, there's no need for it. So you're adding all that extra electric heat usage, and that makes your bill go sky high. So in November of 2017, I said I'm done with it, and went on Amazon or actually on eBay and ordered an Emerson Universal Heat Pump Defrost Control. It's a kind of one-size-fits-all electronic defrost control that features not only time temperature defrosting but also demand defrosting. Now this is where things make more sense. The way demand defrost works is it keeps an eye on the outside coil temperature, but also it measures the outside air temperature. And essentially it knows when the outside coil needs defrosting when the temperature of the outside coil gets drastically below the outside air temperature. See, when frost builds up on the outside coil, it blocks airflow. Well, the coil gets colder and colder and colder, and then, of course, eventually you just have a big block of ice. So, the demand defrost control knows when your actual outside coil needs defrosting, which eliminates the vast majority of unnecessary defrost. And also, this particular Goodman unit, replacing that control also gave this thing short cycle protection and brown protection and other protections it didn't have. Yeah, the defrost control board that used to be in this thing only offered very simple time temperature defrost control. You know, some defrost control boards will also offer protections for the compressor. Let's say if your power blinks out, it won't try to start back up right after a power blink. Well, this one used to try. And during the summertime, we had a power blink once while this was running, and it did start back up. Well, that was because the reversing valve shifted, and it let off the pressure off the head for a second. But in many cases, you know, if your unit shuts off and immediately tries to start back up, it can do some serious harm to the compressor. And a lot of times the compressor will stall, and it'll trip the overload, and sometimes trip the breaker in your house. So yeah. The new defrost control that's in here offers a short cycle protection, brownout protection, and other things. And from my knowledge, pretty much all Train units, and I think Lennox, offer demand defrost. Some Carriers might offer it, I'm not sure, but I think Carrier is one of the brands that does time temperature defrosting. So you have Carrier, Goodman, you have Grand Air, among other different brands. Many brands out there, to this day, are still using time temperature defrosting. And it's ridiculous, because let's be honest, when your heat pump is defrosting, it is less efficient than an electric furnace. Yes, it's less efficient than an electric furnace, because your electric furnace or the heat strip is running when this thing's defrosting, but because this is acting as an air conditioner, it's taking a lot of heat off. It's taking heat out of your house, so the air coming out of the vents is drastically cooler than it would be with just the backup heat running. Another reason that heat pump defrosting can be very inefficient is when your heat pump defrosts, when it shifts the reversing valve to go into cooling mode, it's lost all that pressure that's built up on the high side to give you the heat that you have. So once it completes defrost, it has to start over again. So with heat pumps, they take about 5 to 10 minutes or so to achieve their maximum efficiency. It takes them a little while to get their head pressure up to where they run at their maximum efficiency. So yeah, while defrosting is necessary with heat pumps, particularly air source heat pumps like this here, they should design these things to where they defrost as little as possible. Because I tell you, back in early 2017, when this thing was still using time temperature defrosting, and I didn't have the wood stove at the time, just a fireplace, which I don't think ran much that day. It was a cold, cold day. We actually had snow on the ground. It was cold outside. I think we had a low temperature of like 13 or 16, something like that. Well, this thing set to 90 minutes on its time temperature defrost control. It made enough defrost cycles to where the daily electric usage for that day was like 74 kilowatt hours, which is quite a lot. On average, I use about 15 kilowatt hours if I'm not heating or cooling, so it gives you an idea. In contrast, early last year, 2018, when we had a cold snap and I was at work, so the wood stove was not going and this thing was running most of the time, the backup heat had to come on quite a bit, which these 2 days I'm talking about, the backup heat ran quite a bit as well. But with this time temperature defrost control installed, this thing did not defrost much, if any, at all. My electric usage that day was like 41 kilowatt hours, so talking about at least 30 kilowatt hours less electric usage, which is quite a bit that was saved due to the lack of unnecessary defrosting. One of my friends, her and her mom moved into a house not too far from here. It's a 2-story house, about I want to say 1,400 square feet. Not a very big house, but it's a 2-story house, and it has 2 heat pumps, one for the first floor and one for the second floor. And this was their first time really, I think, living in a house with a heat pump. And of course, with heat pumps, you don't get hot air out of them unless it's like 50 degrees outside. You'll get warm air out of the vents, but if it's like 23 outside, the air is going to feel cold, but it's warmer than the return air, so it actually does heat the home, and is actually still more efficient than an electric furnace at that temperature. But their bill, I think they said their bill was like $300 for 1 month. And when I had stopped by their house one evening, it was like 36 degrees outside. Just getting out of my car, hear one of their heat pumps going to defrost. I'm thinking to myself, yeah, I bet you that defrost was not necessary. And they have 2 carrier units, so that's kind of, I figure what's going on. And I think what's going on is the time temperature defrost control is still set to 30 minutes. See, that's another thing. I know I mentioned this a little late now, but yeah. From the factory, a lot of manufacturers, including Goodman, set the defrost control on a time temperature unit. They set it at 30 minutes. And the defrost control has selections of 30, 60, and 90. And technically, the installer of the unit, when they install it at the house, wherever the house is located, what kind of climate it's in, they're supposed to adjust the defrost control accordingly to that climate. So let's say a home running out in a desert on a cold night. There's not going to be near as much moisture as, let's say, a house running on a cold night near the side of a lake or a pond. So, that essentially means that there's less defrost necessary. And I tell you, that with time temperature defrost control, you simply cannot avoid unnecessary defrost and a freaking waste of electricity. Gotta tell you, this time temperature defrost control is such a waste of power. It's such a waste of energy. And I'm surprised, with the way parts of our government are, that they don't actually outlaw time temperature defrost control altogether. It's an old technology, and should have died as soon as electronic defrost controls came on the scene, because that's essentially what it is. On these newer heat pumps that have electronic controls, there's no excuse for it. They should be able to make better use of the microprocessor to use an algorithm that uses a time temperature defrost logic rather than this cheap stuff that just uses a little basic microchip PIC microcontroller with a open close switch that closes at a certain temperature, opens at a certain temperature. It's such a waste. So yeah, guys, I apologize. This video is all over the place. But yeah, I've been thinking about this kind of recently, especially when I visited my friend's house and noticed they were having high bills with heat pumps. Yeah, heat pumps, when they're properly installed and properly sized to the home, they can save you quite a bit of money. But with many heat pumps still using time temperature defrost logic, that can still be a waste of power in some cases too. Okay, I'm going to continue this video a little bit longer now. I'm back inside where it's warm. So with time temperature defrost controls, they can really rob your electric bill, especially when it's really cold outside. Like for example, if it's in the 20s or teens, and let's say especially on a dry night where defrosting is totally, well I'm not going to say totally, but where you don't need a lot of defrost cycles to keep the outside coil from being restricted. I tell you, just for example, I got a calculator pulled up here. Let's say your heat pump defrost control is set to 30 minutes, which is like I had mentioned outside. From the factory, they're mostly set like that, and they rely on the installer to set them properly, but many installers simply don't do it. So in a climate to where maybe a 90-minute defrost interval would be more appropriate, the thing is still defrosting at 30-minute intervals and wasting a lot of electricity. So, for example, there's 60 minutes in an hour times 24 hours a day gives us a total of 1440 minutes. Let's say that it's so cold outside, you know, in the 20s, that more likely than not, the defrost cycle will simply time out because the outside coil will not be able to reach 80 degrees in many cases. So, on a 30-minute cycle, you would have 30 minutes of runtime and 10 minutes of defrosting. So now this is kind of a worst case scenario. Let's say the unit is running 24 hours a day. Now in many cases that wouldn't be the case, but if it's like in the 20s or the teens outside and it stays cold throughout the day, and if the heat pump is not properly sized for the house, for any reason it has a hard time keeping up, it's going to run constantly. There were times in 2017 and 2018 when of course I wasn't home, or it was before I had my wood stove, that the heat pump would run for about 12 hours constantly. It would get to a point where it had to stay on constantly to keep up at about 10 o'clock that night, and 8 o'clock the next morning it would finally be able to shut off. So that's actually yeah, it's crazy. So we take 1440 minutes, we divide that by 40. That means on a single day, if the thing is running constantly, you would get 36 defrost cycles. But let's get a little more closer to reality here. Let's say the thing is running for about 16 hours a day. And let's say it's cold enough outside to where the thing doesn't reach the defrost termination temperature, so it runs for a full 10 minutes of defrost. So 16 hours times 60 minutes gives us 960 minutes. Divide that by 40, so 30 minutes of runtime and let's say a 10-minute defrost cycle. That's 24 times that the thing defrosted. Multiply that by 10. That's 240 minutes that the thing is spent defrosting and running your electric heat. So if we take that and divide that by 60, that's 4 hours of your electric heat running. Pull up a second calculator here. So let's say your electric heat is a 10 kilowatt strip. So that means it would use 10 kilowatt hours per hour of runtime. So that's 40 kilowatt hours right there. Multiply that by, that's $3.20 of electricity used that day. So yeah, just think about that for a moment. $3.20 just used that day in defrosting. I'm hoping my calculations are correct, because I mean I know it might seem dramatic, but it's true. Electric heat uses a lot of energy. And that's another reason why we want to limit the amount of defrosting as much as possible. So with heat pumps that have demand defrost installed, many times when it's cold outside and the humidity is low, where the point where a time temperature defrost control board would put the unit in defrost, the demand defrost will say, okay, the cool is fine, I don't need to defrost, I'll just keep running. And save you, the customer, lots of money on your electric bill. So yeah, that's heat pumps, as I mentioned, they're pretty neat systems, and when they're properly installed, that can save you quite a bit of money on power usage. But in a case where the unit is undersized and is running constantly all the time, even at pretty mild temperatures, and the thing has a time temperature defrost board set to 30 minutes, I mean, you'll have a high bill. You'll have a high electric bill. And just the time temperature defrost thing alone, this is simply, single-handedly, the biggest thing that annoys me with heat pumps. Is that why are so many of these manufacturers still using this logic? Not only does it use a lot more electricity, but also it's harder on the unit, because the thing is having to shift back and forth between heat and air conditioning a lot more often than it would otherwise have to do if it was only defrosting when defrosts were warranted. So anyways, hope you guys enjoyed this video. Thanks for watching. Well guys, that's it for this one. But it doesn't have to be. There's plenty more videos on the channel to check out. Also, if you liked the video, please click the like button. And if you absolutely hated it, there is the alternative button as well. But yeah, please subscribe to the channel. I definitely appreciate it. And remember to click the bell so that we get notified of all updates. Also, if you're interested in things aside from computers and technology, check out my second channel. It's CubeComp MTDX. Over there you'll find videos about weather, elevators, bicycling, and pretty much whatever else I figure out to upload. So yeah, anyways, hope you guys enjoyed this video, and thank you for your support.